I wanted to focus on the fraction work because that's usually when people start having the trouble. Okay, so before I actually get to the problems on the worksheet for 2.3, I'm just going to kind of review a little bit what we did on Tuesday. Since we don't have a, let me get this chair away. Since we don't have a ton. Okay, so let's just kind of go over some more steps in the solving equations. On the last week, we started off with, let me write a couple problems up here. So these two problems were from 2.1, where we used the addition and multiplication property to cancel out in order to get the x by itself, right? So these, since this was added, what did we do to knock out that plus 7? What's the opposite of it? Subtraction, right? So that's what we did to both sides. Now, I'm going to use this red and see if, can you see that, Takara? Try to do different colors. So this right here, if I subtract the 7 off of both sides, because if you do anything you do to one side, you have to do it to the other. Now, another thing I saw occurring in the classes that I had on Tuesday were people not keeping their equal sign in the same spot. And I'll show you a good example of that here in a minute. So this right here, that plus 7 minus 7 cancels. So x equals, remember to keep your equal symbol always in the same spot. If you move it around, it's going to mess up your sign. So this 15 minus 7 gives me 8. So there, x would equal 8. Here, solving for this x. So since this one was subtracted, in order to remove it, I need to add it. Plus 6, plus 6. So the minus 6 plus 6 cancels, so you're left with x equals 12 plus 6, which gives me 18. Okay, the next thing that we covered which is different is 3x equals 15 like that, and let's say negative 6x equals 15. So we covered some like this. These were different, right? We get rid of these numbers differently because it's not added or subtracted. If it's hooked on, remember the point, when it's hooked on, the way you get rid of the hooked on numbers is you divide by them to both sides. So those 3's cancel. I'm just left with that x equals here 15. That's divided by 3 gives me 5. Okay, up until now, everybody seemed pretty smooth. Now, this one has a couple of different issues that I did see a little bit of trouble with. Now, this right here, this negative 6 is hooked on. It's not subtracted, right? Even though it's got a negative hooked on with it, it doesn't say 6 minus x or 6, plus x or anything like that. That says negative 6 hooked on to that x. So what did we do with this hooked on number? We divided by it. That's exactly what I'm going to do here. I don't change the sign or anything. So if I'm going to divide by this, I divide by exactly what it is. This negative 6. Negative 6. So these negative 6 cancel. So I'm just left with the x equals. Now, here's another place where we ran into a little bit of trouble. You have 15 over negative 6. Now, remember, in your TI-84, since this doesn't divide evenly like the 15 over 3 did, remember, your TI-84 does that dirty work for you. What do? You put it in exactly like it shows. 15 divided by negative 6. So put that in your calculator. 15 divided by negative 6. So it should look just like that. When you hit enter, since it doesn't divide evenly, it's going to give you a decimal. But remember, what is the magic that changes that decimal into its already reduced fraction? Remember what we did. This is going to be your friend this semester. Math, enter, enter. Changes that decimal into its reduced fraction. So now you can see that 15 over negative 6 reduces to negative 5 halves. Okay, let's look at a couple of other reviews. Here's one where we definitely ran into trouble, and it had to do with keeping that equal sign where it needs to be. So it might be a good idea on each problem before you go to the next level is go ahead and bring down that equal sign so you don't accidentally move it. This is one where it accidentally got moved on several people's. So we're at the point where we have x's on both sides of the equal sign. So what do? We canceled out the small x. Which one is the small x here? This 1x, right? So let's get rid of it by subtracting its x. If I do it there, I have to do it on the, here's my equal sign. I have to do whatever I did here on this side. So if I subtract x here, I have to go to the other side and find my x's and subtract x from there. So here, 3x minus 1x gives me 2x. Bring down this plus 5. I haven't even gotten to my equal sign yet, right? It's still all on the left side of the equal sign. Now drop down that equal sign. So what is left on the right side? If I had x, but I took away x, I have nothing, right? So you just put a 0 on that right side, okay? The mistake that people were doing was not liking that 0 and putting that 5 over there, which messed up their signs. If you move the equal sign in the middle of a problem, it's going to change your signs to what they don't need to be, okay? So now that I have a 0 over here, again, bring down your equal. So let's see. X is on the side that I want it to be on. I want to get it alone now, right? Remember, X is a snob. It likes to just be by itself. So let's see. I need to get rid of, remember, the hooked on numbers always last. So don't mess with this 2 until the very last step. Get rid of that plus 5 with a minus 5. Bring down the 2x. Plus 5 minus 5 cancels. So now on the right side, I have 0 minus 5. If you have 0 and you take 5 away, now you're down at negative 5. And your last step is to divide by the hooked on number, which is the 2. So now the 2's cancel. So there's my x equals negative 5 divided by 2. If that doesn't divide evenly, right? And if you put that in your calculator and hit math, enter, it still tells you negative 5 over 2. And that's just because that's in its simplest form already. It doesn't reduce. Negative 5 over 2. Okay? So that was definitely one that people had trouble with. Okay, and that was actually, if you want to reference that, this 2.3, that's like number 1 in 2.3. So if you keep getting number 1 and 2.3 wrong, you need to reference this problem. That is probably the reason why. Okay? All right, let's see what else we got into. All right, let's just do one more before we get into what we're going to do new today. Okay, just a several step problems. So now we get to the point where we have parentheses. So remember how we remove the parentheses is whatever the number is that was bumped up against it, you were going to do what's called distribute that number, which means multiply everything in the parentheses by the number that is bumping up against the parentheses. So let's keep our equal sign where it goes. I don't want to accidentally move it around. This negative 3x is just going to come down. So now, remember your signs. I have negative 5 is what I'm multiplying both of these things in here by. So negative 5 times 4x gives me negative 20x. Then negative 5 times, remember we're multiplying, negative 5 times positive 1 is negative 5. I haven't done anything to the right side yet, so I'm just going to bring it down. 6x plus 2. So there's that first step. Now, second thing is I'm going to bring down my equal sign again. Keep it straight. Let's clean up this left side. I got too many terms over there. Right? I don't need to see these two terms. So I did see a couple of confusing things on this. If these on the same side of the equal sign, you have like terms, you're putting them together. You're not trying to cancel them out. If they're on the same side of this equal sign, I need to think, okay, what is it? Since they're together, what is the same thing as negative 3 put together with negative 20? That's the same thing as just saying negative 23. So there's no reason to write those as two separate terms if they're on the same side of the equal sign and they both have x's. Just put them together. So these are just joining hands to become negative 23x instead of writing them separately. Drop everything down. Drop down that minus 5. I still haven't done anything over here, so I'm still dropping down to 6x plus 2. So, no like terms on this side of the equal. No like terms on this side of the equal. So now I'm moving to the step that says, are there x's on both sides of your equal symbol? Yes. There's a negative 23x on this side, and there's a 6x on this side. You don't want that, right? X wants to be alone, which means the first thing it has to do is choose which side it wants to be on and then kick everybody else off that side. So I'm going to cancel, it doesn't matter which one, I am going to cancel out my small x. Who is smaller, negative 23 or positive 6? Well, the negative number would be smaller than the positive number, right? So let's cancel that one. How do I cancel out a negative 23x? I'm going to do plus 23x. Oh, I forgot to bring down my equal. There's my equal, trying to keep it straight. So I added 23x to cancel that. If I did it on this side of the equal, I got to go find the x's on the other side of the equal and add 23x to them too. So let's see. X is gone there. Make sure you bring down the symbol. I'm bringing down that -5. Let's see, when I put these x's, I put the 23 with the 6, so now I have 29x. Bring down my +2. So now x has chosen that it wants to be on the right side of the equal symbol, right? If it's chosen it wants to be over there, everybody else on that side has to get off so the x can be alone. So let's see, who needs to go away first? Get rid of the +2 with a -2. So let's see, that +2, -2's cancel. So all I'm left with is the 29x over here. So it's getting closer to be alone. What do you have over here? If you're not good with this, punch this in, please. You don't want to make your mistake adding and subtracting with positives and negatives. -5 -2 gives me -7. And then divide by what's hooked on. So I'm dividing by 29. So there's my equal, the 29's cancel. There's my x all alone, which is what it wants to be. -7 divided by 29. If you put that in your calculator and hit math enter, it's going to tell you -7 over 29 because it is in its simplest form. -7 over 29. Okay, let's get into our new stuff, which is the end of 2.3 stuff. I'm gonna open up my chat real quick. I meant to do that earlier. So if anybody has any questions. We're about to get into the fraction stuff. Okay, so in 2.3 now, let's look at number 7 if you have your handout from the week 2 folder. It says -8/7r plus 4r equals 1/4 r plus 73/4. Oh my gosh, all those fractions. I cannot stand it. Not only do we have fractions, what makes this even worse is that our fractions don't all have the same denominator. So the first step is going to be to get rid of those fractions. The way that you're going to do that, and the problem even makes you find what's called the least common denominator first. It says find the LCD of these 3 fractions. So what you're looking for, you're looking at all the denominators. So you've got essentially 7 and 4. You're trying to find the smallest number that 7 and 4 will both go into. Not what goes into them, but what they go into. The easiest way I think to do it is automatically go to your biggest denominator. Between 7 and 4, that would be 7. So let's see. 7 times 1 gives me 7. So the first thing that 7 is going to go into is 7, but does 4 go into 7 evenly? No. Let's find the next number that 7 goes into, which would be 7 times 2, which gives me 14. But does 4 go evenly into 14? Not evenly. Keep going with this 7. 7 times 3 is 21. 7 goes into it, I know. All these numbers 7 goes into. That's what I'm finding, are the numbers that 7 goes into. Then I check to see if the 4 also goes into it evenly. The first one I get to where the answer is yes, that's going to be your least common denominator. So let's see, 21. If you divide 21 by 4, will it give you an even a number? No, it's going to give you a decimal. Look at this next one though. What's 7 times 4? It's 28. Does 7 go evenly into 28? If you're not sure, do 28 divided by 7 in your calculator. It should give you a number that's not a decimal. Does 4 go into 28 evenly? Yes, it does. So 28 is your least common denominator. That is the very first number that 7 and 4 are going to go into evenly. Here's what you're going to do with that 28. Let's see if my blue works. This 28, you're going to put up top of everybody. Can y'all see that 28? I'm trying to use a different color so it doesn't blend in. So even if you, so every term on both sides gets a 28. So 28 here, 28 here, even if you're not a fraction, you get the 28. I'm just gonna do it in black. So everybody gets a 28 on this side, everybody gets a 28 on this side. Up top. Now, here's the magic. The reason we're using 28 is because we know that 7 goes into 28, and so does 4. So we're going to use those 28s on every single place and divide out that bottom denominator. What I mean is, before I do any multiplication, I'm actually going to reduce, what is 28 over 7? 28 over 7 just turns to a 4. Gosh, I can't see that. I'm trying to do it in different colors so that you can distinguish and not get all. So this 28 over 7 turns into a 4. So you're left with this now. 4 over negative, 4 not over, 4 times negative 8. We're going to do that in a second. We're going to keep going through this step. We're going to do several of these. This one, you're going to skip that division step because there's not a denominator down here to divide that 28 with. So go to the other side of your equal and do the same thing. You've got 28 divided by 4. Well, 28 divided by 4 is just going to turn into a 7. Same thing. 28 divided by 4 is just going to turn into a 7. So look at all your denominators. They're all crossed out. There's no denominators left. So use that 28. Go to every single fraction. Divide out the bottom. Now we're going to multiply what's left. So let's see. Here, the 28 over 7 canceled. Turned into a 4. We're going to multiply the 4 times this negative 8. So 4 times negative 8 gives me negative 32R plus, this one still has a 28, right? Because it didn't cancel at the bottom. So I'm going to multiply. I'm going to do it in my calculator, not in my head. So what am I multiplying? What's left? 28 times 4R. So 28 times 4 gives me 112. So now I have 112R. Over here, the 28 divided out the 4 and turned into a 7. So I'm left with 7 times 1R, which leaves me with 7R plus, what do I have here? The 28 canceled the 4 and turned into a 7. So I'm left with 7 times 73. Again, I'm going to punch that in so I don't make a mistake there. 7 times 73. 73 times 7 gives me 511. So now look at your equations. It took us a little bit of work, and we're going to do several of these to get the hang of it. It took us a little bit of work, but now we have an equation that does not have fractions. So let's clean up this left side, because here's my equal sign. These R's are together on the same side. So don't write them separately, write them together. And what do I have? I have negative 32R plus 112R. I'm not going to chance making a mistake there. Negative 32 plus 112. So if I put that together, it gives me 80R. I haven't done anything over here, so I'm just going to drop down to 7R plus 511. All right, bring down my equal. So I've cleaned up this side. There's not any like terms on the right. So now I'm to the step where I say, okay, R's are on both sides, so they got to choose. Cancel out your small one. So I'm going to cancel out my 7R this time by subtracting 7R minus 7R. So now let's see, I've got 80R minus 7R, which is 73R, equals 7R minus 7R cancel. So let's see what I'm left with over here. I'm left with 511. So the last thing that needs to occur for R to be by itself is to get rid of that 73 that is hooked on. So I will divide by 73, divide by 73. So the 73's cancel. I have R equals. Do that division and see if it divides evenly. If it doesn't divide evenly, math enter it to reduce it. So let's do 511 divided by 73, enter. Gives me plain old 7. All right, I'm going to do another one that I'm going to make up that's going to be just like this. So my answer is probably going to come out crazy. But we need some more practice with doing the LCD, the least common denominator, and using it to cancel out those fractions. Okay, so again, I'm just going to make it up. All right, I'm going to go a little bit down so we're not in the glare. Okay, so again, I'm just making this up. It's going to follow the same rules, though, just to get more practice. All right. Denominators all over the place. 5, 3, and 5. So my two different denominators are 3 and 5. I'm going to default and go to the biggest one. And let's see. I got to find what 5 goes into. So 5 times 1 gives me 5. So I know 5 goes into 5, but does 3 go into 5? No. So I need to go to the next thing that 5 goes into. So 5 times 2 gives me 10. Does 3 go into 10 evenly? No. So I got to keep going. 5 times 3 gives me 15. So I know 5 goes into 15. Does 3 go into 15 evenly? It does. We have a winner. 15 is going to be our LCD. That's the number that we're going to put on top of everybody. Whether you're a fraction or not, you get the 15. So let's see. Everybody's getting 15. 15 here, 15 here, 15 here, and 15 here. What's the point of the 15? What did this step do? It found the number that every single fraction is going to be able to divide into. The 5 is going to go into the 15, so is the 3, and so is the 5. So we're going to be able to use that 15 to cancel out our denominators. That's the next step. What is 15 over 5? Well, that's just going to turn it into a 3. So 3 is what's left there. This one skips that step, right? Because it doesn't have a denominator to cancel. Moving over to the other side of my equal sign. 15 over 3. What does that turn into? 15 over 3 turns into a 5. Here, 15 over 5. That turns into a 3. So again, you got rid of all 3 of those denominators. If you don't have denominators, then you don't have fractions. So let's see what's left. The numbers that are left from when you did all that canceling, you're going to multiply it times its pair, what it's paired with. So let's see, what is this 3 paired with that's left here? It's paired with a negative 3x. So 3 times negative 3x gives me negative 9x plus, what is this 15 paired with? It's paired with a 12x. So I'm going to multiply 15 times 12, which gives me 180x. There's my equal sign. Here I have a 5 left. What is it paired with? It's paired with this 5x. So 5 times 5x gives me 25x. Plus, what is this 3 that's left over here paired with? It's paired with that positive 2. So I'm going to have plus 6. There's your equation without fractions. All right, left side needs some cleaning up, right? Here's my equal sign. I have my x's. These need to be cleaned up. So I'm just going to put those together. What do I need to put in my calculator? Negative 9 plus 180 to see how much that is. Negative 9 plus 180 gives me 171. So I've got 171x left on the left side. Just going to bring this side down. 25x plus 6. So now I'm to the step where I have x's on both sides. They need to choose. I'm going to cancel out my small one, so I'm going to subtract the 25x from both sides. Drop down my equal. 25x is canceled. So over here on the left, I've got 171x minus 25x. So 171 minus 25 equals 146x. Bring down my plus positive 6, so I'm just bringing down a 6. And divide by what's hooked on. So I'm dividing by 146 on both sides. So it looks like this is probably going to come up with some kind of crazy fraction. So x equals, in my calculator, I'll do 6 divided by 146. 6 divided by 146, which gives me 0.041095, some kind of crazy answer, right? If I do 6 divided by 146, that's when you work your magic and do math, enter, enter. So math, enter, enter. So that reduces your fraction for you to 3/73. Okay, I'm going to put one more on the board since I do have people at home doing this, and I've had a couple of people ask questions on this. I'm going to put one on the board. Now that you've seen me do a couple, let's see if you can do one. I'm going to make it up again. So again, it's probably going to come up with some crazy answer. But follow those same steps. Find your LCD. And use it to cancel your fractions. Oh. All right, with those numbers, you're going to come up with something crazy. Find your LCD first. Here, let me put this 23/3. So your denominators are 3 and 4. So use your 4 to go find the first thing that 3 and 4 will go into. I'm going to try to pause that recording so this is not. Unpause it. So 4 times 1 gave me 4, but 4 didn't go into it. 4 times 2 gave me 8, but, oh, excuse me, 3 doesn't go into it. What's 4 times 3 though? It's 12. Will 3 also go into 12? Yes, so there's your number. That's what you're going to use. That's what everybody's going to get, whether you're a fraction or not. So bring down your equal and give everybody a 12 up top. Even if you're not a fraction, you still get a 12. So everybody's got 12s up top. That 12 is going to cancel out your denominators. So that's the next step. 12 divided by 3 is going to leave me with a 4 up there. This one skips that step, right? It didn't have a denominator to cancel. There's my equal. 12 divided by 4. Again. Not again. 12/4 leaves me with 3 up there. Minus 12/3 leaves me with 4 up there. So once you go through and you cancel all those denominators, you multiply what it's left with. Its pair that it's left with. So what is this 4 left with? It's left with a 2x. So 4 times 2x leaves me with 8x plus 12 times 7x. Is that 84? Yep, so 84x is what's left here. There's my equal. Multiply the pair that's left here. This 3 is paired up with this 3x. So 3 times 3x leaves me with 9x minus This 4 is paired with that 23. So let's see. 92. So brought down the minus, 4 times 23 is 92. So again, now we're set up to not have any fractions. Let's see. Left side needs some cleaning up, right? Because here's my equal sign. Since they're on the same side, I'm just going to put them together. What is that? 84 plus 8 gives me 92x. Bring down this 9x minus 92. So since you have x's on both sides, now it's the time where they got to choose. So I'm going to cancel out my small one, which means I'm going to subtract that 9x. Bring down my equal. Keep everybody straight. 92 minus 9. What does that give you? 83x equals 9x minus 9x cancel. Be careful here. What are you bringing down? That negative 92. The sign comes with it. And your last step. It took on, so divide by 83. So now I have x equals, I have no idea if that reduces, negative 92. Negative 92 divided by 83, enter, it gives you some crazy long decimal, right? If you divide it out, it gives you a crazy long decimal. So math, enter that, and it doesn't reduce, right? It still tells you negative 92 over 83. Okay? Now, I am going to go back to the worksheet now and work numbers 8 and 9. Number 8 is another fraction one, but I kind of feel like we just can't get too much practice on that. Number 8, 3/8 x minus 1/3 x plus 6 equals 1/6 x. So look at this one. Fractions everywhere, different denominators everywhere. This time my denominators are 8, 3, and 6. I've got 3 different ones. But I'm going to use the same process. Find your biggest denominator. The biggest one between 8, 3, and 6 is 8. So the first thing that 8 goes into is 8. But 3 doesn't go into 8, and neither does 6. Now we're finding them, since there's 3 different ones, all 3 numbers are going to have to go in to these numbers over here. So let's see, what is 8 times 2? 16. Does 3 go into 16 evenly? Which means in your calculator, you would just divide 16 to see if it would divide by 3 evenly. And it doesn't, so I don't even need to check the 6. Since they all have to. Well, let's go to the next number. 8 times 3 is 24. So I know 8 goes into 24. Let's try this. So the way you check it is I know 24 divides by 8 evenly, because it gives me a whole number. Check the 3. So do 24 divided by 3. It goes in there evenly. So now I need to check that 6. So do 24 divided by 6 and check it evenly. If it would have had a decimal, I would have had to keep going. If any of those would have had a decimal, I would have had to keep going. So 24 is the number that we are going to use. Everybody gets a 24 up top. Doesn't matter if you're a fraction or not. You're getting 24. So 24. 24. The 6 gets it. There's my equal sign. Go ahead and bring it down. So everybody gets 24. Now go to every fraction and divide out your denominator. So let's see. This 24 divided by 8 leaves me with 3. So I'm left with a 3 on top of that one. This one has a fraction, so I'm going to divide it also. 24 divided by 3 leaves me with 8. So I'm going to have an 8 left there. This one skips that step, right? It doesn't have a denominator to divide out, so I just skip that step on this one. Move over to the other side of the equal sides. 24 divided by 6 leaves me with 4. So all my denominators are crossed out. The next step is to go multiply the pairs that are left. So let's see, what's left in this pair? I have 3 is paired with the 3x. So 3 times 3x leaves me with 9x minus, let's see, this 8 is left with a 1x. So let's see, what's that going to be leaving me with? 8 times 1x gives me 8x. Bring down, plus 24 is paired with 6. So if I multiply that, 24 times 6 gives me 144. Bring that, there's your equal sign. So on the other side of the equal sign, I'm left with a 4 that's paired with a 1x. So I'll have 4x. Okay. Now, next step is, can you clean this up any? On the, here's my equal sign. 4x is, there's nothing to put it together, but look on this side. Look at these x's. Put those together, right? The same thing as saying 9x minus 8x is the same thing as saying 1x, or just x. Bring down my plus 144, and just drop down my 4x here. Drop down your equal sign. So the left side is cleaned up. Nothing can combine here. The right side is cleaned up. Nothing can combine here. But x is now's the step where the x's has to choose, right? Cancel out your small one. And the reason I say that is that's just going to keep your x's positive if you always cancel out your small one. So my small one between 1x and 4x is 1x. So I'm going to cancel it by subtracting 1x. So let's see, the 1x minus 1x canceled. So I have 144. There's my equal. 4x minus 1x is 3x. Who's hooked on? What do I need to divide by? Whatever is hooked on, which is the 3. So drop down my equal. My 3's cancel. There's my x by itself. And 144 divided by 3 gives me 48. So x equals 48 on that one. And last one. This one has all those decimals. It's got all those decimals. It's just a lot of calculator work, and it's being careful what you're punching into your calculator. .24 times 10,000 minus 0.03y equals 0.07. I'm going to run into that thing. You know what? Let me move it over to the left because I don't want to mess it up right off the bat, going over that bar. Let me move over here. 0.24 times 10,000 minus 0.03y equals 0.07 times y plus 10,000. All right, the first thing I notice is, first of all, decimals everywhere. The second thing I notice is parentheses. So remove the parentheses. So you're going to multiply this 0.24 times that 10,000. Keep your equal sign straight, especially on a problem like this. And you're going to multiply this 0.07 times both things in that parentheses. So let's see. I'm going to just punch that in my calculator. 0.24, clear it. 0.24 times 10,000, which gives me 2,400. I'm going to drop down this minus 0.03y. There's my equal. Over here, 0.07 times y is just 0.07y. So 0.07y. But now I have to multiply the 0.07 times the 10,000, right? Because this 0.07 goes to both of those terms. So bring down the plus. And in your calculator, 0.07 times 10,000 and that gives me 700. All right. Look at bring down your equal sign. And look on either side for like terms. This is a plain number, and that's a y number. So there's nothing to clean up there. I can't put those together. On the right side of the equal, this is a y, and that's a plain number. So I can't put those together. So I don't have any cleaning up to do on the left and the right, but now I'm to the point where the y has to choose. So remember, I'm going to knock out the small one. And the way I tell which one is small on this one is, look, this one's negative y, and this one's a positive y. So since the negative is always smaller than a positive, I'm going to knock out the negative one. Here's the thing. It won't be wrong. Doesn't matter which one you cancel. If I'm knocking out this minus one, I'm going to have to do what? How do you knock out minus with a plus? 0.03y. If I do it on this side, I have to do it on this side. Under it's y. So what am I adding? I'm adding 0.03y. So let's see what happens. These cancel out, right? That was the whole point of doing it, is to get rid of this y on this side. So what's left on the left side? The only thing that's left is this 2,400. Bring down your equal. Add those y's together. Again, just punch that in your calculator. You're going to have 0.07 plus 0.03. And what did that give you? It gave you 0.1 y when you added that together. Drop down this plus 700. So now we're to the step where y has chosen its side, and now it wants to be alone. Well, if y, and remember, you don't get rid of what's hooked on until the very last step. Doesn't matter what it is. You don't remove what's hooked on to the y until the very end. So I need to get rid of this plus 700 at this step. So to get rid of plus 700, I will minus 700. Minus 700. So let's see. On the left, I've got 2,400 minus 700, which gives me 1,700 equals the positive 700 and negative 700 cancel out. So all I'm left with is 0.1 y. Is it hooked on? Then you divide by exactly what it is to cancel it. So I am dividing by 0.1. Divide by 0.1. So my 0.1's cancel. There's my y alone. So now all I need to do is this math right here. 1,700 divided by 0.1, which gives me 17,000. Okay? So this week, what is due is 2.2 and 2.3. Now, I'm also going to show you, because I know I've seen a couple people have gotten some problems wrong, but I want to make sure that you can see that you can go back in and rework similar problems. You know what? I think I can do this for the people in the class so they don't have to. I'm gonna try to do something real quick. What to do? Okay, so y'all can see this, and then at home, y'all can see the internet too, right? Okay, I think I figured it out so that y'all can both see it at the same time. So if, let's go to number, I'm going to go to your homework real quick. I know this computer's weird, so. Okay, so your student links is where your homework is. My Math Lab, all assignments. So I'm going to go into 2.3 to maybe one that you would have gotten wrong a few times. Say number 6, and you had a red X next to it. So I'm going to show you what happens. I'm just going to type in an answer and get it wrong. Then it gives you another chance, right? Because it's still down here. You can still type in something different. Still got it wrong. So the third time, it's going to tell you final check, right? It says final check down at the bottom. So final check. So I got it wrong. So if you say, okay, you said, okay, I'm done with that. I need to take a break from that problem. When you come back into this homework, so say you come in later to your assignments, and you go to 2.3, you say, so you might have all these questions you got right, but you have this 6 that has a red X next to it. If you open it back up, look down at the bottom right. It'll be right down here. This screen just doesn't show it. Right down here, it's going to say similar question. If you click on that, it's just going to give you another question like that one. It'll just have different numbers and give you the opportunity to get that point. So even if you have wrong answers in your homework, if you go back in your homework, and you can also click on this down button up here and find out which ones have green checks or red X's. The ones that have a red X, you can re-click on them and work a similar problem and try to get it right. So you can do that as many times as you want. Okay? All right, I'm going to stop sharing now. Does anybody have any questions on that? I'm going to try to get through. Okay. All right. Well, then everybody have a good weekend. 2.2 and 2.3 is due on Sunday at midnight. And also, if you haven't taken the course agreement quiz, which is in Blackboard, you need to do that. You need to check your email because I sent a video on how to get to that course agreement quiz if you haven't done that. All right. Have a good weekend.